Okay, so to do the partition for rectangular coordinates, we just start with the x because the limits on x don't depend on anything else. They're just from negative r to r. So it's really easy to write that, whereas the partition for y is going to depend on the value of x. So we're going to establish what x does, and much the same way we did this. We said x goes from negative r to r. Now, what are the limits on y for typical x, right? So we're going to partition this, and then we're going to partition this. But we can't partition this until we know what the partition is here, and you see why if you don't already. So you got negative r equals x naught less than x1 less than so forth equal to xn equals big plus r, okay? And then your partition for y is going to depend on where you are in the partition for x. Okay? Now implicitly, when we do the partition, and we should write it out, and you should write it out every time you do a partition, xi star, I'll write it out the way it should be, xi star is in the interval xi minus 1 xi, and that might be hard to read, but I think I wrote that out when I did it 2 weeks ago, okay? So you just write out where xi star is. It's got to be in the ith interval, right? That's kind of implicit, but I want you to make it explicit to keep reminding yourself of what's going on here until it becomes second nature. Then you can start saying, okay, it's implicit. And if you do it in a test and make it implicit every time and don't actually write it out and never make a mistake because you did that, okay. Okay? As long as you got all the details in there, I'll know that you understand where xi star is. Anyhow, so now what's y going to do? Well, y is going to go from here to here, where x is now xi star, right? So you have negative square root of r minus xi star squared less than or equal to y naught equals, equals y naught less than or equal, well, it's all the way up to y sub m. And it's not just y sub m, because you don't have to use the same number of intervals in your partition here as you do here, or here, or here. Okay? So it's going to be y sub m sub j sub I. Okay? So m sub I is the number of partitions you're going to use when you're partitioning for x sub I star, right? So every x sub I star gives you an interval that you have to partition on y. Okay, so you got a bunch of x sub I stars, you're going to have to partition a bunch of y intervals, right? Okay? And that equals then the square root of r minus x I star squared. Okay? So that's how you write out this partition. Okay? Now what's your typical increment look like? It's a rectangle. Delta xi star, right? And, you know, when I wrote this out, I was a little careless. I wasn't careless last time. You got y0. It's not really y0. It's y0 sub I. because of course this partition depends on your xi star. It depends which x interval you're partitioning, right? Okay, so that would then be less than or equal to y 1i less than or equal, and so forth, okay? And instead of putting a subscript on m, yeah, I'm going to leave that to be, actually to be rigorous, I'd have to call it m sub I, since I'm using two subscripts in each of these, okay? There are other ways to notate it, but that's going to be important. You'll see why in a minute. So you're going to have a delta xi star and a delta yi. And it's not a delta xi star, it's a delta xi and a delta yi. And I've written that small, but I'm going to draw a big one here, okay? And you have your sample point, which has what coordinates?
xi star, yi star.
Xi star, y, and I'm using, okay. I'm going to write this out a little better. Yeah, let me rewrite the partition and make sure I make sense of it. So yeah, we need a bigger picture of this, just so we can think about it when we set up the integral, which is going to be really easy, okay? So let me kind of redraw this. And I'm going to just kind of put a big X through this. It's mostly right, but it's too small and too crowded to read and to allow me to put the subscripts in where I need to, okay? So we're going to redraw it.